I used to be young, excited about the future, optimistic. That was before, when I thought everything would run smoothly and I would just build applications. And then it all went wrong. Hello? I'm questioning all my choices right now. So let's get started. This is the board that we're going to be working with. It has a NVIDIA Jetson Orin Nano module in it, and it has a super carrier board. If you don't know what those words mean, check out my previous video where I go into the different types of Jetson devices. And it looks like this. I'm gonna do a little close up. Come with me. So we have the Jetson module, we have the fan, and we have the carrier board. And this is the one that we can connect to with all the peripherics. It's alive! Oh, you sweet summer child. We can look at it together. Downloading and installing a lot of things by itself. Okay, in the meantime, I'm going to open up the GitHub repository where we have all the instructions for the next phases of this project. The course that we're building up is based on the repository that Seeed Studio has put together with all the different chapters and basics that you need to get started with the NVIDIA Jetson ecosystem. You may be thinking, what on earth is going on, Iulia? Why are you coming to us from a futuristic, hellish world to warn us about being too excited about technology when that's what your whole channel is about? Well, that's because this happened. Now, I don't want to get into the details because I am still too fragile to talk about it. But along with the Jetson that may or may not be usable anymore, I refuse to look too closely at it and find out. All the footage that I had on the board also vanished. So I'm going to attempt to recreate whatever happened instead of the footage that I was going to use. Then we have 3 separate goals for today, or major things that we want to get set up. First of all, I want to set up everything I need in order to be able to code and develop the models and the solutions that I want to work on. So that includes setting up the Python environment, the IDE that we're going to work with, something like Docker, getting access to the Jupyter environment, figuring out how CUDA and TensorRT is going to work. So everything that has to do with programming. Then we want to set up everything that has to do with the robotics hardware. We're talking about installing the right ROS version, which can take a little bit of time, especially because although this is of course going to be running Linux and Ubuntu, it is running it in a particular Jetson kind of way. So I'm a little scared that there'll be some issues to iron out there. And we also want to set up the ISAC lab and ISAC sim, which also only work with specific versions of ROS. So we have to find a common denominator that works smoothly with everything. And finally, I want to see how this deals when interacting with actual hardware, and perhaps already set up the foundation for what we're going to want to run later, which is the SO101 ARM projects. So there we have it. The goals for today is setting up programming, ROS framework, and physical hardware integrations. Now, I have my inklings about which of these is going to take longer and be more frustrating, but I'm really curious what your vote is. So let me know in the comments before we get started, which of these 3 chapters do you think is going to take the longest and be the most problematic? Now, what I'm most hesitant about is the ROS setup, because we really have to make sure we get all the compatibilities right. So for example, if we set up Ubuntu 20, we're going to want to run ROS Foxy. If we set up Ubuntu 22, we're going to want to run ROS Humble. All of this, of course, is ROS 2. We're not even going to look at ROS 1. That's nothing we want to touch anymore right now. But what we specifically have to pay attention to is that we're also going to want to integrate that with ISAC Lab and ISAC Sim. If we want to run ISAC, we need it to be Ubuntu 20 Plus and ROS Humble. So ROS Foxy is just immediately out of the running. We're going to go with Humble. We need CUDA 12 Plus. We need Python 3.10. ISAC Sim is compatible with Python 3.11 only. Well, that's already contradicting it. See, that's what kids don't get these days. Things don't just run out of the box. That's a child's dream. In adults' world, you need to get all the versions to be compatible. What does that mean? see, what Iulia from yesterday is trying to do, silly girl, is install the right operating system on her laptop. You would think that would be easy. You probably run Windows or Linux. And if you do run Linux, which you should for robotics, you probably have a nice, new, smoothly running one like Ubuntu 24. Well, you're wrong, because you see, Ubuntu 24 doesn't run with Isaac Sim or Isaac Lab or JetPack 6, which is the only JetPack that you can get on a device like the Jetson Orin Nano NX Super, which is the one that Iulia bought and was so excited to use. Oh, she was so excited. But it doesn't work like that. You see, if you want to use JetPack 6, you have to use Ubuntu 20. That's just one version before Ubuntu 22. Easy, right? No, you see, because if you try to install Ubuntu 20 on one of your new devices, because you know people in tech, they need to have the newest devices with the greatest GPU and the awesomest board. We now have my PC that is set up with Ubuntu 24. It's been a few hours. Well, they're not compatible with old software. So Iulia will try to install Ubuntu 20 on her PC that she's very happy with because it can run Baldur's Gate 3 on the highest resolution, but she will fail. Hours and hours of frustration, she will fail. Then she will think, oh, it doesn't matter. I will install it on my laptop instead. If this doesn't work out, I'll try to put Ubuntu 22 on my laptop instead. Well, that will eventually work, but only, again, after hours and hours of debugging and trying to reinstall Ubuntu from a USB stick. She does it 4 times before it works. 4 times. So as soon as the startup configuration finishes, which we're already at about 25 minutes and counting, when that's done, we'll set up the timers for the different sections that we want to set up today. And hopefully we finish today. And try she did. After managing to install Ubuntu on her laptop, Iulia went on to flash her Jetson board. Now, it was running in the background for about 2 hours because she thought it just needed to do some stuff. I don't know, computers do stuff. But instead, she forgot to take it out of the safety reset mode. Well, technically she didn't forget. The documentation just didn't mention that she should do it, but I feel like she could have figured that out a little bit earlier on her own. Anyway, then she got it running. Wow, green NVIDIA screen. What a sight for sore eyes. Back when I knew what joy was. We're gonna start with what I think should be the simplest part of this setup, which is the Python environment. This is something that you can set up on any computer or device that you work with for your programming. We need something like an IDE. And of course, the official IDE of the Back to Engineering channel is PyCharm. I have a lovely relationship with them and they've agreed to sponsor the channel as our official IDE. Thank you guys so much. I love you for that. It's going to be great. So we're going to set up PyCharm as our main IDE, or the place where all the code is going to live and happen. And within that, we can set up the right Python version. We're going to set up all the packages that we're probably going to work with for stuff like computer vision later down the line. So you may be wondering, hey, that's something that I already do right now on my laptop. Why do you need to set all that up on this particular device specifically? And that's because we're going to leverage the particular architecture of the Jetson device and all the GPU goodness that comes with it. It comes out of the box with JetPack and with CUDA, which is something that NVIDIA developed to be able to leverage the GPUs in a really, really nice multi-threaded parallel programming kind of way, which means that rather than running a program and waiting for every single step to run subsequently, we can distribute the work to a lot of nodes, or in this case, threads and blocks and a grid. I am CUDA. When you run with CPU, it takes me 20 seconds to compile. When you run it with the GPU optimization, it only takes 4 seconds. I swear there's proof of this. I just don't have the footage. This also allows us to work with tensors very efficiently using something called TensorRT. I already made 2 videos about TensorFlow in collaboration with PyCharm, so you can watch it if you want an introduction to what tensors are or how to set up your first project with TensorFlow, including an appearance from the lovely Richie Mini. Then Iulia will need to install ROS. And Iulia had nightmares about installing ROS because the last time she tried to do it, I am trying to install ROS. I expect it to take a really, really long time because last time it took 2 days. Enter. Boy, I sure think this will run for 2 hours. It already worked. What? Wait, run turtle sim. Enter. Now surely this will not. What? It works! Wait a damn minute. Are you saying that if you install the right version of ROS on the Tier 1 supported system, in this case namely Humble on Ubuntu 20, it will just run immediately if you follow the documentation in 5 minutes instead of taking 2 hours because you thought Mint is the same thing as Ubuntu? Well, my apologies to the ROS community. I was wrong. You were right. This is actually quite nice and kind of surprisingly the fastest, smoothest experience I've had this week. So thanks for that. Sorry I couldn't get it on camera. Let's move on. So now that the installation of Python and CUDA and ROS had gone so incredibly smooth, as proven by the footage that I totally had, and sadly you'll just have to believe was really there and it really happened, Iulia went on to her next challenge. Because isn't this why we're here on this channel? To see actual robots do things. I was going through the LeRobot instructions and again things were running more or less smoothly until we got to the section about PyTorch. Now, see, earlier in the process when I was installing everything I needed for Python, some of the commands didn't run, but that didn't really stop the CUDA part from running, so I thought, well, it's a problem for later Iulia to deal with. It's me, it's later Iulia, and I'm dealing with it. Everything here is horrible and it sucks. Turns out that although I had installed CUDA and I got it to run, I didn't add it to the path. So here's Iulia taking another 4 or so hours to figure out how to do that with the help of a lot of Claude tokens and having to actually upgrade her Claude subscription. So this video actually lost me an additional 90 euros. Everything's horrible here. I think this works. So we got to the part of LeRobot that I know how to do. Oh, if this actually works, it's gonna be a miracle. So in the end, we had to do the freaking... I don't even know how to explain what it is that went wrong and how we fixed it. I don't know how people used to do this before Claude. I guess a lot of Stack Overflow. But the amount of specific errors and dependencies and rabbit holes that we went down on just to get to the right version of PyTorch, specifically with the right version of Torch Vision that works with CUDA and with the JetPack stack that we have. And I would love to explain it to you and lay it out as the solution, but really this only applies to the very specific Jetson Orin Nano NX 16 gigabytes board that I have. So if you have a different setup, you're probably going to run into different issues. I don't know. The best thing to do is just like go back and forth, figure out something that works and like freeze it. I saved my wheel so I can use it from now on. Yeah, it's very complicated and difficult for a first time setup, but I'm curious now how quickly, once that's done and we accept that as a sunk cost, let's get these boys running, right? We've done all this before in our LeRobot video that I'm gonna link. So there's nothing new, we're just making sure that the USBs are connected, LeRobot's installed, we're gonna set up the leader and the follower, set up the joints overall and seeing the range of them, doing the teleoperation, and hopefully that should run. For my previous setup, this is where a lot of stuff got stuck, but that led to me doing it on Windows. So I'm hoping that now that I have the right operating system, none of those problems exist anymore, and this is just super smooth, the same that we had it with ROS. The ROS video took me 2 days, but that's because I had the wrong OS. So again, the thing that took me 2 days this time around hopefully makes ROS and LeRobot each run in like 10 minutes. Please don't let that be another self-fulfilling disaster prophecy. Are you gonna work? Oh my god. Okay. Okay, this works. So this is running on okay. Well, don't stop working now. Jesus. Oh my god, hello, did you just turn off? Okay, well, we got the LeRobot arms running, but my Jetson board might have died. Thanks for watching. I'll see you in the next episode. Oh my God. I'm questioning all my choices right now. But we got that running in like 10 minutes. You win some, you lose some. Oh my goodness. I'm very sorry you had to see that. I'm very sorry I had to live through that. I don't really have much more to add. I will continue to try to revive my Jetson board from now on and try to believe that it's not me, even though this has now happened twice. I'm off to ICRA, to a really big robotics conference, to see a lot of robots that actually work, which I will try not to take to heart. And I will see you in the next episode, if I have a board to run things on.